Welcome to my video on simplifying expressions using properties. So we've evaluated expressions with a variable and followed order of operations, and we've also learned our properties. Now we're going to look at steps of order of operations and justify each step using a property. So let's look at example number 1. It says state the property that is used for each step. So we want to know how we got from step 1 to step 2. So if we look here, this was replaced with these two numbers. So remember when we evaluated expressions, we said that if A equals B, then A can be substituted in for B. So all we're doing is taking out the letters and substituting a number. So this is called substitution. And it's also substitution anytime we take something and replace it with a number and we don't already have a property for it. Because some of the properties like identity inverse, it gets replaced with a certain number. And so we can call it that property. But if it doesn't have a property name and something's being replaced, we call it substitution. Okay, now from step 2 to step 3. So I noticed that grouping is the next step. So we did this step and two opposites became 0. So when I add two opposites, that's the additive inverse. Okay, and the additive inverse says when two opposites are added together, you always get 0. So now we have to see how we get from step 3 to step 4. I noticed the 1 times 6 was replaced with a 6. So that is the multiplicative identity. Because the multiplicative identity says when you multiply a number by 1, you get the same number. So now I need to justify step 4 to step 5. I notice that the 4 times 0 became a 0. So anytime you multiply something by 0, that is called the multiplicative property of 0. And now I have to justify step 5 to step 6. So notice 6 plus 0 was replaced with a 6. So anytime you add 0 and you get the same number, that is the additive identity. Okay, let's move on to question number 2. It says evaluate when A equals 3. So I notice that all of the A's were replaced with a 3. So to get from step 1 to step 2, the 3 was substituted in for the A. So that is substitution. And this is a U here. Now, I notice in step 2 to step 3, I notice that the 3 and the 400 changed order. So let's put this right here, showing that these changed order. And this is called the commutative of addition. Okay, now I need to justify step 3 to step 4. So notice the 1/3 times 3 got replaced with a 1. So anytime you multiply something by its reciprocal and you get an answer of 1, that is the multiplicative inverse. And then the last step, 1 times 400 got replaced with a 400. So anytime you multiply a number by 1 and get the exact same number, that is the multiplicative identity. Okay, go ahead and turn the page. And let's look at question 3. It says evaluate when a equals 5. So notice here that all the a's got replaced with a 5. So we'll just underline the whole thing. And anytime you replace a letter with a number, that is called substitution. Now I need to justify step 2 to step 3. And notice it's in the exact same order. But if you look carefully, in step 2, the negative 25 and the 5 are grouped together. In step 3, the 5 squared and the negative 25 are grouped together. So we're going to underline this whole part. And when something gets regrouped, that is called the associative. Of addition. Now we have to justify step 3 to step 4, and I know that I looked for grouping, and inside the grouping here I see an exponent. So I'm going to underline 5 squared, and that was replaced with a 25. So since I don't have any special property for that, we are going to call it substitution because the 25 was substituted in for the 5 squared. Now I need to justify step 4 to step 5. I still have grouping here, so I notice that the next step was 25 plus negative 25, and it was replaced with a 0. So remember, when you add opposites and get 0, that's the additive inverse. Step 5 to step 6, I noticed that the next step was multiplication. So 3 times 5 got replaced with a 15. So since I don't have any other property for that, it was substitution because the 15 replaced the 3 times 5. Step 6 to step 7, I noticed that the 0 plus 5, that's the next step because you add or subtract from left to right. 0 plus 5 was replaced with a 5. Anytime you add 0, that is the additive identity. And then step 7 to step 8, the 5 minus 15 got replaced with a negative 10. Since we don't have special property for that, we call that substitution because the negative 10 was substituted in for the 5 minus 15. So let's look at the fourth and final example. Question 4 says evaluate when n equals 4. So we notice in the first step here that the n squared was replaced with a 4. So we call that substitution. Now from step 2 to step 3, I notice that I have a grouping symbol here, and inside the grouping symbol I notice exponents, so they did 4 squared next, and replace it with a 16, so that's substitution, because the 16 is replacing the 4 squared. Step 3 to step 4, I notice that there's a 20 here, so the 16 plus 4 was replaced with a 20, so that is also substitution. Step 4 to step 5, I still have brackets here, or grouping. So 20 plus negative 4 was replaced with a 16, so that's also substitution. So there's a lot of substitution here before we get to one of our other properties. So now I want to go from step 5 to step 6. So notice the 16 times 116 was replaced with a 1. So anytime I multiply reciprocals and get 1, that's the multiplicative inverse. Step 6 to step 7, the 6 times 0 was replaced with a 0. So anytime you multiply by 0 and get 0, that is the multiplicative property of 0. And last but not least, 1 minus 0 got replaced with a 1, so that's substitution. That concludes our notes on simplifying using expressions. I hope you have a great day.